In this video, we are going to do some exercise in trigonometric functions. Let us start by drawing our right angle triangle. I have my angle, I have my opposite is 4, my adjacent is 3. And the question is, we have to find sine theta, tan theta, and cosec theta. I am very sure your first question is, how am I going to find sine theta? The question is, we don't have the hypotenuse, and we know that sine theta is equal to the opposite divided by the hypotenuse, but we don't have the hypotenuse. But remember, we did the Pythagoras Theorem, and this Pythagoras Theorem will help us to find our hypotenuse. Let us say our hypotenuse is equal to x. We know that the opposite square, a square plus b square, is equal to c square, is our Pythagoras Theorem. In this case, we know that we will have 4 square plus 3 square is equal to x square, which this x represents our hypotenuse. With this implies that our x, which is equal to the hypotenuse, is equal to the square root of 4 square plus 3 square, which is equal to the square root of 16 plus 9, which is equal to the square root of 25, which is equal to 5. Now we have our hypotenuse. The next step now is to find sine theta. Sine theta is equal to our opposite divided by our hypotenuse. This is equal to, the opposite is 4 and the hypotenuse is 5. Let us proceed. The cosine function cos theta is equal to, yes, it was not in the equation, but let us calculate it just to do it. We have our adjacent is equal to our adjacent divided by the hypotenuse, and it is equal to 3 divided by 5. Now we have our tan function. Tan theta is equal to our opposite divided by the adjacent, and it is equal to 4 divided by 3. And at the end, cosec theta, which is equal to 1 all over sine theta, which is equal to 1 divided by 4 divided by 5. Since our sine theta is equal to 4 divided by 5, so for the cosec theta, we will obtain 5 divided by 4. So this was an exercise to show you how to use the Pythagoras theorem and these trigonometric functions. They are very important, very, very important. Let us solve another example for you people to understand it more clearly. I have a triangle like this one. This is a right angle triangle. I have my angle here, theta. I have the opposite to be 7, and I have my hypotenuse to be the square root of 65, but I don't have my adjacent. To find my adjacent, I will apply the Pythagoras Theorem. The Pythagoras. I know that the Pythagoras Theorem states that a squared plus b squared is equal to c squared. Now, I will apply it here. I know that my a represents my opposite, so I will have 7 squared plus my b represent my adjacent. I will have x squared is equal to, and my c squared represent my hypotenuse. I will have 65, the square root of 65, all that square. Now I will have x squared is equal to 65, because I have the square root of 65 all square. The square root and the square cancel each other, and I will obtain 65 minus 7 square. Now I will obtain my x will be equal to the square root of 65 minus 40 minus 49. This implies my x will be equal to the square root of 16, which is equal to 4. Now with our adjacent, we can now calculate all the trigonometric functions we need. Let us calculate the sine function. We will obtain the opposite divided by the hypotenuse, and this is equal to, my opposite here is 7, and my hypotenuse is the square root of 65. I still have, here is my sine theta. Now I will calculate the cos theta. The cos theta will be equal to my adjacent divided by my hypotenuse, and this is equal to, I calculated my adjacent here, and my adjacent was 4. I will have 4 divided by the square root of 65. Now my tan theta will be equal to the opposite divided by the adjacent, which is equal to, the opposite is 7 and the adjacent is 4. Let us proceed. I will now calculate my sec theta, and it is equal to 1 all over the cosine function cos theta, and it is equal to 1 divided by 4 divided by the square root of 65, which is equal to the square root of 65 divided by 4. Let us proceed and calculate the cosec function. My cosec theta will be equal to 1 all over sine theta, and this will be equal to 1 all over, I know that my sine function is equal to 7 all over the square root of 65, so I will have 7 divided by the square root of 65, and this will be equal to 65 divided by 7, so the square root of 65 divided by 7. Now I will calculate cot theta. Cot theta is equal to 1 divided by the tan theta, and this is equal to 1 divided by, I know that my tan theta is equal to 7, divided by 4. And I'll go down, I proceed, I have my 7 divided by 4, and this is equal to 4 divided by 7. This is the end of this video. I hope you learned something new. Please subscribe to my channel. See you in the next video. Ciao.